You can choose between 1,000 Saudi riyals today or 1,210 riyals exactly 2 years from now. The later amount is larger, but larger at a later date is not automatically better. Under a 10% annual comparison rate, these two amounts are financially equivalent at today's valuation date. Change the rate or move the date, and the answer changes. Stay to the end because we will delay one payment by only 1 year and turn a positive project value into a negative one without changing the payment amount. This is not a lesson about four unrelated formulas. It is one system for moving money between dates. Compounding moves a present amount forward, discounting moves a future amount backward. A discount factor exposes the multiplier used in that translation, and net present value repeats the process for every cash flow before adding them at one common date. First, build the timeline. Then identify the valuation date, the date to which every amount must belong before we compare it. A money amount without a date is incomplete for a time value calculation. SAR 1000 today, SAR 1000 after 1 year, and SAR 1000 after 5 years are equal currency amounts, but they are not automatically equivalent financial values. We therefore draw a timeline and choose a valuation date. In this video, the valuation date is today. Every future amount must be translated back to that point before we compare or add it. The rate must use the same period as the timeline. 10% per year and 2 years fit together. In code, 10% is 0.10 and the period count is 2. A monthly rate cannot be dropped into a yearly period count without conversion, and an annual rate cannot be applied 12 times unless the compounding convention actually says how the rate is divided or converted. Always name the rate, the period, and the compounding convention before calculating. Next, compound today's money forward. We will see why the changing base creates future value. Begin with SAR 1000 and a 10% annual rate. Under simple interest, the same 100 reals is added each year because interest is calculated only on the original principal. After 2 years, the amount is SAR 1200. Under annual compounding, year 1 adds 100, creating 1100. Year 2 earns 10% on that larger amount, adding 110. The ending amount becomes SAR 1210. Now the future value formula has a reason to exist. 1 plus the rate gives a one-period growth factor of 1.10. 2 years means that factor is applied twice. 1.1 squared equals 1.21. Multiply the present value, SAR 1000, by the accumulation factor, and the future value is SAR 1210 at year 2. Now reverse the journey. Start with future money and translate it back to today. Suppose you are promised SAR 1210 after 2 years. We are no longer asking what today's money becomes. We are asking what amount today would grow into that future payment under the same 10% annual rate. The timeline, rate, and horizon remain unchanged. Only the direction reverses. Present value is therefore not a different kind of money. It is the same economic amount expressed at the earlier valuation date. To move backward, divide the future value by the same accumulation factor. SAR 1210 divided by 1.1 squared equals SAR 1000 today. This gives us an independent check. Move 1000 forward at 10% for 2 years and obtain 1210. Move that amount backward using the same rate and horizon and return to 1000. If the two directions do not undo one another, the rate or period basis changed somewhere. Instead of hiding the backward translation inside division, we can expose it as a discount factor. The 2-year factor is 1 divided by 1.1 squared, or approximately 0.826446. Under this positive 10% rate, every 1 future real at year 2 is worth about 0.826446 reals today. Multiply SAR 1210 by that factor and return to approximately SAR 1000. Next, Place several payments on one timeline. Translate each one separately, then combine them into net present value. Consider a synthetic project. It requires SAR 1000 today. It is expected to return SAR 600 after 1 year and another SAR 600 after 2 years. Put every amount on the timeline before calculating. The initial payment is negative because money leaves at time 0. The later receipts are positive because money enters. Time 0 cash already belongs to today, so its exponent is 0 and it is not discounted. Choose today as the valuation date and use the same 10% annual discount rate. The year 1 receipt travels back one period. 600 divided by 1.1 equals approximately 545 rials and 45 halalas. The year 2 receipt travels back 2 periods. 600 divided by 1.1 squared equals approximately 495 rials and 87 halalas. Now, and only now, do the three values belong to the same date. Add the signed present values. The net present value is approximately positive 41 rials and 32 halalas. Without discounting, the project pays 1,200 after costing 1,000. The raw net cash flow is positive 200 rials. After accounting for timing at the chosen rate, the net present value is only positive 41 rials and 32 halalas. A positive net present value means the discounted sum is above 0 under these cash flows, dates, and this rate. It does not guarantee profit, prove that the forecasts are accurate, or automatically recommend the project. Now change one input at a time. Predict the direction before revealing the answer. Keep every amount in the 10% rate unchanged. Move only the final SAR 600 receipt from year 2 to year 3. Before we calculate, predict the direction. Will net present value rise, remain unchanged, or fall? Under a positive rate, a later positive payment normally has a smaller present value because it must travel backward through one additional discount period. The year 1 receipt still has a present value of approximately 545 reals and 45 halalas, but the delayed receipt is now divided by 1.1 cubed. Its present value falls to approximately 450 reals and 79 halalas. Add the signed values and net present value becomes approximately negative 3 reals and 76 halalas. The payment amount did not change, only the date changed. Yet the project moved from positive 41.32 to negative 3.76. Return the final payment to year 2 and vary only the discount rate. At 0%, no future cash is discounted, so net present value is positive 200 rials. At 10%, net present value is positive 41 rials and 32 halalas. At 20%, the future receipts receive less present weight and net present value becomes approximately negative 83 rials and 33 halalas. Under a positive rate, raising the rate ordinarily lowers the present value of positive future cash flows. The foundation formulas accept a rate. They do not determine which real-world rate should be used. In this lesson, 10% is a stated comparison assumption. It is not automatically a promised return, inflation rate, risk premium, loan quote, or market price. Selecting a rate is a separate valuation decision. The current beginner net present value contract also assumes one constant rate and equally spaced periods. Irregular dates, day count conventions, changing yield curves, taxes, and financing structures require a more advanced model. Now, verify the full system. We will navigate 4 connected FinTech Builder lessons and reproduce the hand calculations in code. Start with compound interest and highlight how each period earns on the amount already accumulated. Then open present value and future value. Focus on the valuation date, forward versus backward movement, the formula pair, and the independent reverse check. Continue to discount factors. Highlight the difference between the rate and the unitless multiplier. Then use the lab to change the rate and waiting time. Finish on cash flow timelines and net present value. Highlight the signs, the separate exponent for each payment, the synthetic worked example, and the playground. The supplied production environment calls three verified foundation functions. They calculate present and future value, discount factors, and cash flow net present value. Pin and verify the package version before recording. Pass the same synthetic inputs used in the hand calculation and compare the resulting numbers, not merely the formatting. The package's verified tier reproduces the canonical calculation in TypeScript and Python fixtures. That confirms cross-language parity. It does not independently validate the cash flow forecasts or the chosen discount rate. Finally, clear the most dangerous mistakes. Then compress the entire topic into 4 actions. First, do not compare cash amounts while hiding their dates. Second, 10% in code is 0.10, not 10. Third, match the rate period with the time period. Fourth, time zero cash uses a factor of 1 and is not discounted. Fifth, outflows are negative and inflows are positive. Sixth, each future payment uses its own period count. Seventh, retain precision through the calculation and round at the display boundary. Finally, present value is an equivalence under assumptions, and positive net present value is not guaranteed profit. The whole lesson can now be compressed into 2 inverse factors and 4 actions. Build the accumulation factor to move money forward. Take its reciprocal to obtain the discount factor. Multiply one future cash flow by that factor to find present value. Repeat for every cash flow. Preserve the signs and add the translated amounts to obtain net present value. Present value and future value are therefore not different species of money. They are amounts stated at different dates under one declared translation rule. Final quiz. Question 1. At 10% per year, what amount today is equivalent to SAR 1,210 in 2 years? Question 2. If a positive future payment moves 1 year later under a positive rate, does its present value normally rise or fall? Question 3. Should time zero cash be discounted? The answers are SAR 1,000 today, its present value normally falls, and no, time zero cash already belongs to the valuation date. A money amount is incomplete without a date. Compound forward to find future value. Discount backward to find present value. Use the discount factor to expose how one future unit translates to the valuation date. And for several payments, discount each one separately before adding the signed present values. But one question remains: where does the rate come from? And what changes when a quoted rate is simple, compound, nominal, effective, or real? That is video 5, Interest Rates Explained.